Hello,
Yes, how are you?
I'm good, thank you. And you?
Yeah, I'm good, and good to hear that everything went fine so far.
Yes.
Okay, don't worry. I think the most important thing is if anything happened like that. I think I mean I'm not sure if there is something in the future, but I'm talking about it's better to how to say to communicate that earlier to avoid
Okay.
any confusion. Yeah, yeah.
Yes.
Okay.
Next.
So
Sorry.
yeah, no problem. It's okay. No worries. I think it should be fine. Just let me know how is your exercise so that we catch up whatever remaining.
I'm having problems while running it. I'll share.
Okay, so it went fine. What about, did you manage to write, um, you remember there was an exercise where we need to create a method that writes the data that we have, like for example, the marks of the students, the average, the student number. We needed to write that into the file. Did you manage to create that? I mean, it took us some time, right? You remember when we, yeah.
I do remember. Yes, I was able to get that after.
So it means that you was able to write the content that we produced or printed out into a file,
Yes,
right?
it was.
Okay. And how did you, may I ask, how did you actually, what formatting did you use to be able to concatenate the data in the text file? Which means that what is the separation that you put between each mark and another? Did you put comma? Did you put space? What did you put?
To separate the marks, I used the /T option.
Yeah, but you use the same in the file.
Yes, I did the same.
Okay, that is interesting. So I would recommend something else. So just, yeah, if you still have the code, yeah, you already shared with me. Okay, that's excellent. Okay, Word, and you already invited. Can you show me the event guest, please?
It says already invited, but I don't understand. Oh, let me just delete this.
Okay. Aha, I got it. Okay. So yeah, now it's good that you shared with me. So the point here that uh, um, uh, I think I need to say touch wood. Here we need to improve a little bit. So in such a case, we need to create a variable that's called flag variable, and we don't need to specifically call it a flag. We don't need to that. That when I say to you a flag variable, it is a variable that can be true or false. Okay.
Yes.
So we said we can use found as a flag variable. We initialize it to false, and once, okay, so you are in a loop. Wow. Okay, this is not a format for the if. The if typically have a condition, but what you're trying to do here is you just searching. I got it. I thought you are looping through it. Which is also correct, not bad. So if word in content, you said reads. Okay, I think I need to troubleshoot the code more to make sure that it's running as it should. This content, I would like to print it here. So print content. And yep, not only that, I would also like to come inside here. Okay, press enter, print copy, put that inside the print. Word in content. Okay. Yeah, run. So it seems that when you printed the content, it brought me out this. So
But it also printed the name, chemo.
Yep, but it printed it out. So it seems that so let me be frank with you. Recently, this replet have some issues, okay? And many times we see that it goes out, they close it and they put it into maintenance mode. So there is some errors, but so if I mean, the true thing is that when you print the content, it show me that. And the thing is, I think you already put it correct. I got it. So I think maybe we need to try to put this in before the word. Because when you put the slash in after inserting this, you are actually putting a new line after the chemo, but not before it. But suppose, I mean, if I am here at the Maya, I don't want to be at the same line like Maya. So okay, the point is, okay. So if we have this already written, then I would recommend close this, please, and open it again. So close it, and try to open it. Hopefully that updates the content of the file. Wow, it's not updated.
And the flag variables, it should be false, shouldn't it be? Because the word is not in the content of the file.
It is. It
True.
is.
Here it is, but not in the actual file.
Not in the actual file, but it seems that they have a delay. It seems that they have a delay in writing the content of the file to the file itself. But it seems that it is in the memory. That's why I'm getting it here. Okay, so is that an issue to us as a coders? No, it is an issue in the replet itself. So as long as I'm seeing it here, it means that, okay, he's showing to me something. So I would say that they might, because you are using a free tier, okay? So they might not write the content of the file immediately. I have seen that a few times with the free tiers. So they might take a few minutes because that costs them money, you know? I mean, at the end of the day, they as a company, they offering you this for free. So writing things to the desk, can you imagine that there is millions of people using their service? So definitely it costs them money. So maybe they somehow want to reduce their costs or cut the cost out. So that's why they don't write immediately, especially with, they know that we are students. So it means that maybe what we are writing is not so important. So I believe that content will be written. Maybe you check after 30 minutes or 1 hour, maybe you will find it there. But definitely, if you see it like that, it means that this, what will be written here. So I would like you to try after 30 minutes or 1 hour, and we check it again, and we confirm it in the next class so that we don't waste more time. Your code is correct, and you should just try like that. So, okay. Yeah, I think you are okay so far. You use a different way, which is totally fine, but okay, that's excellent.
What the ideal way to do it would be?
Sorry again?
Can I see what the
yes,
answers?
Yes, definitely. Definitely. So you should be able to see. So let me see here. Did I give you? Okay. So I would say that this is an example, although we are not using here. So this is a sample answer. So I open the file, I create a flag variable. I loop through every line in the file and I check it. I strip it and then I check it. But here he's checking for not for chemo, he's checking for something different. But it is exactly the same concept. So if we strip, you know, strip what? What does it mean? We remove the spaces before the word and after it. So sometimes, so for example, one of the words that we see, or one of the guests that we see inside the text file is Maya. So sometimes if I press space, you'll not be able to see it. With your eyes, you cannot see it. Okay? And if I compare Maya with a space here, with Maya that does not have space, they will not be equal. Do you understand that? Or that is something difficult to grab?
I can understand, yes.
So that's why he uses strip to make sure that what we are comparing, both sides is actually really equal. There is no spaces before and or after. Sometimes if you put a space here, also that will cause a trouble because you're comparing Maya with a space before or even after, and then with another word that doesn't have any spaces here. So definitely they will give you false if you compare that if they are equal or not. So here they are checking, okay, if line.strip is equal, whatever you are searching for, then he will issue a flag equal true. So he will make the flag equal true. And then once that happens, he will open the file for amend. Okay. And then he will check. If the flag equal false, it means that we did not find the word that we're searching for. He will write it out. So that is how he uses a flag. But your code is not bad. I can't say that it's bad. Okay.
Okay.
So, I mean, if you can find solution naturally, I would not disturb that. But this is another way to do it. I would say that I would stop, except that I would like you to see, give me a second. I would like you to see something because when you join text in a file, I would actually recommend something slightly different. So give me a second. I'm sharing this with you. So one of the common methods to actually, let me check here. Give me a second. I think you can see my screen. So,
yeah.
So if you have an array like that, okay, we are able to use a function that's called join that will actually convert this array into a string, but it will join it together using whatever you put here. So you can put here a comma like that, dot join, and that will produce 1, 2, 3, 4. So it will concatenate all the array content into a string, but that string is actually separated by comma. Why? Because you put here comma. So what if you would like to join using a space or even a dash? So you see here he is using a dash to join all the array content and save it into a string that's called joined. So I would recommend you to use the same method when you are saving data to a file. So in case, okay, we actually, when we was talking about the student, we say student 1, and then we put his marks for the 3 subjects that we have, and then we put an average. I'm giving just sample data. So I would recommend you don't use spaces because spaces are tricky, but the commas are not tricky. So comma, it is very easy to give a command that when you read that, you can split it based on the comma. But the spaces, that can be sometimes tricky because maybe when you enter the data itself, it have a space. Okay, so you will find yourself ending with 2 spaces and you cannot see them. So people, when they save content to a file, typically they don't use space. Comma, dash is also accepted, but and also sometimes they use semicolon like that. So comma or semicolon, very common in separating data in a file. How is that? Is it difficult?
No, no, no. I can understand. Yes.
Okay. Are you able to please write these 3 lines just to test it and confirm that everything is fine? Then we move on.
Okay.
So as part of the homework, I expect you to try save the 2D array in the text file using this join method. And then you just confirm to me next time that you have no issues. Okay?
Yeah.
If you feel that I'm rushing so much, slow me down.
Okay, but I don't feel that way so far. But yes, it prints out the numbers with the dash in between them.
Okay. And just remember, it is a string. Okay?
Yeah.
So I think we can continue. But before we continue, I would like to open a small topic with you. This is also one of the advanced topics that typically it's tough for the students to actually grab it. So I will have to divide it on a few classes. So let me start that small topic, and then we continue back on the classes. So let me, I mean, what I'm trying to do now is that I'm using, typically many teachers will not do that. They will just try to explain the topic one shot. But I noticed that it is better for the brain to keep repeating and talking about certain topic, especially when it is difficult. So, okay. Did you ever hear about recursion?
No, I haven't.
Okay, so recursion, like I'm telling you, is a little bit advanced topic, and it also most of the time, I would say, 70 to 80% of the code questions in the exam come asking us about recursion, and it's sometimes tricky to find solutions. So a recursive routine is a function that calls itself during its execution, and it calls itself many times. Okay. So one of the best ways to actually explain this recursive routine is to look at the factorial problem. So I think you took that in mathematics, right? So
Yes, I did.
okay. So I think I no need to explain why for
Factorial.
factorial. Yes, it's like that. You already know that, right?
I do know that.
Okay, perfect. Then I would say so, but the point here, okay, let me put it this way. So we are able to divide, okay, so we are able to say that this 4 factorial equal 4 multiplied by 3 factorial. And the 3 factorial is equal 3 multiplied by 2 factorial. And so on until we reach 0, which is equal 1. So So again, to simplify a real problem in the real world, and we want to make a code for it, then we need to always simplify it, find the basis of it. So if we just say that 4 factorial equal 4 times 3 times 2 times 1, like that, I mean, then if we have 5, so what should we do? So the best way, especially when we're talking about recursive, we need to divide it this way. So if we divide it this way, it means that this somehow is similar to this, except that it is -1. So, and this is similar to this, except that this 2 is -1. So are we able to make a formula that can help us write this and put it in a function? Yes. So we are able to say that n factorial, it doesn't matter 5 or even 10. Okay, so n factorial equal n. So I would say if it is 10, I would say 10 multiplied by n minus 1 factorial. So I would subtract 1 from here. I put 9 factorial. So this is the formula. How we understand the formula from here. So far, is that clear how we write the formula?
Yes, yes.
Okay, so I understand finding the formula. It takes time, and here.
But I
Yep.
did this.
Sorry.
I did this last year, so I understand.
Perfect. So we call this here the last thing. We call this is a base case. Do you understand that this is a base?
Yes.
This is our end. So okay. So to write a recursive function that keep calling itself, we need a base case. If we don't have a base case, the function will run forever non-stop. So okay. To write the factorial function, so to write a function that calculates the factorial for us using a recursive, we need to write the base case like this. And then we need to put the else. And in the else, we say return n multiplied by the factorial n minus 1. So how is that? That is exactly when we write 4 equal 4 multiplied by 3 by n minus. So, I mean, this is exactly what we wrote just now, right?
Yes.
So this is how he write it, okay? So he called factorial and he passed an input at n, and he put here the base case, okay? So the base case is either n equals 0 or n equal 1, and it returned 1. So this is the base. And he make the recursive part. The recursive part is we using here the formula, and he say that, so if you put n equal 4, so you will find that he put the 4 here. But then this portion, it is, I mean, we're calling the same function again and again, but with n minus 1. So n minus 1, it means that I'm calling the same function with the input 3. And then if we look more, we will find that this function also call itself again with the 2, because every time we run, we say -1 until we reach the base. So once we reach that n is equal 1, then the function will not call itself. So we will see how that works. But yeah, just be patient with me. The point here is that we are able actually to solve the factorial problem using this kind of code. So it is not only that the only way to solve it is the factorial, is a recursion. No, we are able to use the loop like that. And then if you write the loop, so you are able to say that if you pass here n, and you say the loop runs from 1 until n plus 1, and then you pass production. So the n control how many times we run, and then we call production, which is equal 1 in this case, and we multiply it by the value of 1. So if we pass here 4, so I will take value 1, 2, 3, and 4. And once it reaches 5, it will stop because we are ending at
4.
5 because it's n plus 1. So if we pass here 4, yeah, this is 5. Here, the point here that you are actually multiplying 1 plus 2 plus 3 plus 4, which is exactly what we said. If it is 4 factorial, we said that it is 4 multiplied by 3 by 2 by 1. So that is exact. I mean, it doesn't matter the arrangement of or the sequence that they multiply, but at the end they multiplied the same numbers, you know. So at the end, this produce exactly the same result like this. Of course, if you know the for loop, you will say that, oh, that is quite easier. But at the end of the day, you need to understand how recursion work. So let me try to explain that more. Tell me, do you have any basic understanding so far of what recursion does?
Yes, yes, I can understand.
Okay.
Uh, I just have a question.
Yes.
So in the recursion side, we call okay, we don't call the function. We define the function factorial, right?
Yes, exactly.
And at the end, we call it because that's what a recursive function does. And in what
What
part?
do you mean by the end? You mean here? This is the end? This.
Turn. Yes, we
Okay.
call it
Yep.
the function itself. But in what part do we actually write what the function does? So for example, here, there is no part which defines that the number should be multiplying itself. I don't know
Oh,
if you understand my
it's
question.
yeah. Okay, I understand. But here, it is here. Okay,
Okay.
give me a second. Give me a second. I will try to. So I think. Let me see. Let me see. I think no, not this one. This one will not clarify to you. Give me a second. I think I have one slide. Yeah. So yeah, your question is good. And actually, to be frank, the tricky part is that is to understand this and to understand that I mean, you could face recursive functions that do a lot of things, and if you don't really understand what's going here, you will never understand what the code is doing without testing it. So I would say, so here we have n multiplied by something. So let us think together. So if I pass 4, so here I'm defining the function. Here I'm calling it. So I am putting number equal 4 and I'm calling factorial. I pass the input as 4, which is like the n become 4. Okay. And then I'm storing the result somewhere and printing out the result. So definitely I will ask you to run that, because without running and putting some print statement, you will never really be clear about what is it doing. So this is what we call a global scope. This is the factorial function that we have. And then here they say factorial, they pass input to the function. It is called 4. Okay. And then we call the function, which is here. This is the first call. So here we define it. Here it's the main, our main. And that's why he said global scope. And then this is the first time that we call the function factorial. This is the first time. So we call it, and the input is equal 4. The n is equal 4. That's based on our start. And then once we call it with n equal 4, so notice what happened. So in here, it's 4 in this case. And then I call factorial again, but I pass it input n minus 1. n minus 1, in this case, 4 minus 1 equals 3. So I call the factorial with 3 as an input. Okay, so I did not yet calculate anything here, not yet. Then I make another call. And then when I make another call, I allocate a separate place in the memory to call the function, to call the same function in a different place in the area in the memory, but my input is 3. So when you call it with input 3, you check, is it n equals 0? definitely it is not. The n is equal 3 in this case. So it means that you don't run here, you actually come here. And this return will actually call the function again, but with a different input. Now my n is not equal 4. Now here, n is equal 3. So you see here, the n, this is 3, and this becomes 3. And then when I say 3 minus 1, it gives me 2. So have a look at this. So again, I will make another call to the function, but with the input 2. And I still did not perform the final answer for this multiplication or even this multiplication. So, okay, let's just be patient with me. I pass to this function and I allocate another area in the memory and I call the same function again, but with input equal 2. So I will keep doing that until I reach this base. If you do not design your base correctly, the function will run forever and it will cause big trouble. So anyhow, let me see. So the input is 2 and I'm passing my n now become 2. And then definitely 2 is not equal 0. So I will come here. I will find myself with the n equal 2. I will put here 2. And then I say n minus 1 equal 1. So that is what the return is going to do. So it will call itself again, but with the input equal 1. Okay. So when I call it equal with n equal 1 or the input equal 1, I will make a second call. And this is typically the last call that I will do. And then with n equal 1, I will find myself hitting the base. So actually this needs a slight modification here because based on the experience with students, I did some modification. So allow me please to make this modification at the moment to avoid you getting, I think it was here somehow, but I just removed it by mistake. Let me check here. Possibly. No, it is not, unfortunately. So I would say that I can say n equal 1. So if I do this change, I will find myself when n equal 1, I will actually return 1. So if n equal 1, I will not come to make the function call to itself again. So that 1 will get returned to here. So if I return 1 here, it means that I remove that and I put 1 here, and then that will become 2 multiplied by 1. And then I return again, so I remove that portion. Okay, and then of course, you multiply 2 by 1, you are actually as if you are passing 2. So 3 multiplied by 2 is going to be returned again, and you will remove this portion, and we put 3 multiplied by 2, which is what we get from this function called. So it is the same. When you kept calling it the function, okay, you never finished the initial multiplication that you needed to finish. You kept calling until you hit the base, and this returned something solid, which is the number. Okay, and then you pass this number to here, and then that will give you something that you can multiply 2 with, and then you return that here, and that give you something that you can multiply with the 3, and then you return 6 here, and then you multiply the 6 by the 4, and then that will actually return 24. At the end, this will print 24. I think it's a bit complicated, and it seems that I'm about to get you lost here. Am I getting you lost?
No, I can understand better now. Still
Okay.
not.
Okay. So my recommendation, please write this function. And when you write it, before you come here, you do a print statement. And
What am I supposed to print?
you print, give me a second. I put print. You put double quotation, n equal, and you put comma, and you put n. When you
Okay.
do that, you will see that this kind of calls, it happen in the memory. You cannot see it with your own eyes, but to see it, you have to put a print statement. So put this and run with a print. So what I'm explaining today is not the end of recursion. Recursion needs a lot of training, same like classes. So I will keep addressing this every class until we see a lot of examples of how recursion works, because not only factorial, they use it even to check strings, if it is palindrome or not. So and there is a lot of examples and a lot of chances. So we try to cover whatever common examples of recursion, so that I familiarize you how to write a base condition and how to really understand what the function is actually doing. Okay? Because sometimes they give you a function and they tell you, okay, what this function is actually doing. Okay?
Okay.
Okay, now.
Well, where it's written numbers equals to 4, should it not be n?
Can you repeat the question again, please? Sorry.
In line 7, it
Uh-huh.
says number is equals to 4. Should it not be n is equals to 4?
No,
Rather,
no.
okay.
So okay. Let me tell you something. So this is the main, and n is only known to the function definition, and you can put whatever variable that you want to pass. Internally, we will take this number, and then we come here. We will say that n internally, you don't see that. We will, when if you name this a different name, and this is typical that you put them different, they should never be the same, so that it doesn't confuse you also. So we put here a number, right? So this is a variable name number. So internally, when we do the function call like that, this is done for you by the Python without you feeling it and without you seeing it. So he will know that I am passing number to this function as an input. So, and he knows that I am naming n to be used inside the function. He doesn't know anything. I mean, this definition does not know anything about number. So he will internally save the content of number inside n. And from this line on, we only use the n. We don't know anything about number and we don't use it. Is that okay?
Yes.
Okay, good.
Okay, prints n is equals to 4, then 3, 2, and at the end it says the factorial of the number 4 is 24.
Okay, so when you see many n printed, that is because of these calls that we keep calling. And if you somehow move this print out from the else and you put it on top here, you will see that we even print n equal 1. Okay, so just because I put it here, that's why I cannot see when the n equal 1 call is done. But if I move the print out here, you will see it. Can you do that, please, and confirm to me that you're able even to see the n equal 1? Are you confused?
No. Just copying it. Yes, it prints 1.
Okay, so it means that we still keep calling until we reach the base, and then we return back the values and complete the multiplication. Because at the end of the day, when you want to try to multiply n by a function, at the end of the day, we are not able to multiply a number by a function. The function must return something first before we are able to complete the multiplication. So until we reach the base and the base give us how to say, a clear number that we are able to do multiplication with, then we will keep the function, we keep calling non-stop. So, okay, there is something bad about recursion, that we actually consume a lot of memory space. Internally, yes, you don't see that, but if you look at here, you will see we do a lot of calls. So what if you do 100 factorial? There will be a lot of calls, I can tell you. Okay, so that is not good. That's not good at all, and it's not good for the memory. It occupies a lot of space. Yes, you can make a simple function that keep calling itself, and you are happy with that. But internally, it's not perfect. Okay, so I would say that this kind of code is not the best. It's not best for computation. It means that the resources, either the RAM or the processor, is not optimized for this kind of function. And then, other than that, I will continue the remaining in the other classes, and I will switch back to classes because we still have a new concept that we would like to know. Okay. Can you see my? No, you don't see yet anything. I think here. Do you have any question before we move on to classes?
No, not right now.
Okay, so you remember last time we write this function that's called product class, right?
Yes.
Okay, and then this is a kind of exam question that you get. So he will tell you, you write the class that match this description. So what he write here, he describe this is attributes. So this is how he define each attribute. This is the name of the variable, and this is the type of the variable. So he got description that it is a string, width is an integer, height is an integer, frame color is a string. And then we have a constructor. We know that our constructor is something always like this. Am I right?
Yes.
Okay, so we will write our constructor. So we will pass it whatever inputs that he described here. Okay, and then we write these methods. So definitely this need practice. So this is what is the name of this class? Picture class. So the picture class have description. So we have a get description, get height, get width, get color, and set description. So we only have set and get for the description. Other than that, it's fixed. We don't change. We only use the get. So set description, it means that he allow that I'm able to change whatever stored in the description variable that is part of the class. So I will give you this as an exercise to think about it at home. I know that this need more practice, but I need to give you new things because again, we are approaching the end, and I need you to your brain to get use of that. And then if you face a problem with this kind of code, then we discuss it.
Okay.
Okay. So is that okay to you, or you prefer we do it together?
It's fine. I'll try to do it by myself first, and if I have any problems, then we'll do
Yeah.
it together.
Okay. So if I would share with you, this is very common. I mean, this form of question is very common. So that is not only one, that is a picture, and this is the class treasure chest. And there is many questions that take this kind of form. So, and here also the balloon class is almost the same concept. So let me move to the concept that is called inheritance. So did you ever hear about that before?
Not in the context of coding.
Yeah, okay. So I think, yeah, so pseudocode does not have inheritance. So I would say inheritance, it's a way to organize our code in the first place. So if we have classes, we are able to make classes to have relationship between each other. And this relation, when we study it, we will find that it saves us time, and it also encourages what we call code reusability. So again, we have, I mean, the form of relation between classes is that we define a base class, and then from the base class, we find classes that could have relation in the real life with the base class. So from the example, we will see. So we will talk about employees, for example. We will talk about people, classes, and then, so that is something from the real life that we are trying to imitate using code. So have a look at these two classes. We have a part-time employee class and a full-time employee class. So this is the attributes of the part-time employee class. We have name, that is string, age as an integer, hourly rate as an integer also, because he's part-time. So he's not getting a monthly salary. He just paid by the hourly hours he work. And the full-time still have the name and age, because I mean, he's still human. So, but he is not getting paid by the hour. He's getting paid by the monthly rate. So they have similarities and differences. And then we look at the methods for this kind of class. We have the get name and daily wage. We have the get name and yearly salary. So this is common here, and this is different. So when we see that there is two classes that is similar to each other, they have similarity, so we are able to actually organize it in a way that we store common attributes and common methods and in a separate class. And both of them are able to use that common class. Let me just share with you if I would like to convert the current two classes, which is a part-time employee and the full-time employee into classes like that. So that is how I do it. And just be aware of this. Many times in the exam, he tell you declare variables. I think I told you that before. And the
Yes.
declaration must be always with the hashtag because it's comment. There is no declaration in Python. This is the constructor that we have. And the constructor for part-time employee takes 3 inputs, which is attributes, actually. The name, the age, and the hourly rate. We have underscore because that is a private variable. Okay. And then we have the 2 methods. One is called getName, and one is called daily wage. So the daily wage, we need to pass it, the hours, number of hours that we worked, and we multiply it by the hourly rate. So if you have the hours and the price per hour, then you're able to reach something, and then you return it. So we do the same with a full-time employee. We find that we are still having a constructor. The constructor have these 2 things common, as we can see here. Only the hourly rate is different from the monthly rate. We take here 3 inputs. And we have a method also that's called getName. So it means that if I want to know the name of the employee, I'm able to call that function, and it will get me the name of the employee. And then we have something called yearly salary. And this yearly salary does not need the number of hours because typically it is just the monthly rate multiplied by 12. And then we return that. So this function, if you call it, it will return to you how much this guy gets at the end of the year. And daily wage, this will return to you the amount of money that this part-time employee get per day. So based on the number of hours he worked per day, if you maybe work 8 hours or 10 hours, that will be multiplied by the fixed rate, and then we will return his daily wage. So far, is that clear or difficult?
Yes, it's clear. I just wanted to know in this case, what would be the parent class
We
thing?
have, yeah, so we have to create another class, and we call it employee. So that will be the base class. And what we're going to put here, we put the name and the age, and we put the getName methods. So when we do so, it means that we are able to reduce the code that we write for the part-time employee and the full-time employee. So none of them will actually need to create name or age, because if they are able to declare a relationship with the base, they are able to actually use the variables here. And it is done for them automatically. Again, we will look into this, but we're just explaining the concept at the moment. So what is different between the part-time employee and the full-time? Here, he have an hourly rate. Here, he have a monthly rate. Here, he have a daily wage, which is the method unique to him only. And he have a yearly salary. Here, we only have the things that is in common between both classes. So it means that we still have to declare this employee as a class also, same like we did with this. So also let me share with you the possible code that we have. So if you look at this, you will find that this name and age will also be private variables. This is how we make our constructor. Okay, and that is how we make our common method, which is getName. Okay, and this is typical because at the end of the day, when we create a full-time employee, look at here, please. You find that we call that super dot init, and we pass it 2 inputs. When we call super, we are actually calling the base class employee. So, I mean, in the code, you are not going to initiate or create an employee class. No, you design it, yes, but you're not going to call it. So when we call the product class, if you remember, we say P1 equal product. Okay, and yeah, that is totally fine. And we pass inputs to the product class, and that will be passed to the constructor. But in this case, we will never call the employee. Yes, we will design it, but we will never call it directly. The one who will call it and even construct it for us is this line. So it means when you call the word super, it will go to the base class, call the constructor, and pass it to inputs, which is the name and the age. And then it will pass this monthly rate to its attribute, to the class full-time attribute, which is this one. So who will create this a new object from the employee? It is done automatically by this line from inside the full-time class. So this actually saves us time. I understand that this seems to be a little bit complicated from the outside, okay? But that's because we never write a code yet. So I understand that because I'm trying to push things forward, I didn't give you much time to write or even have more examples of the recursion. And I'm almost doing the same here. But so we go a little bit backward, and I would recommend that you write these two classes first, and then from there we see. So on the same file, create a class called part-time employee before we do the base class, before we do any modification, and we move forward from there, so that if I rush too much, then there will be gaps in your understanding. So I cannot risk that. I think I am pushing fast also somehow. So it's fair enough that you write this and try to build an object from it. Is it okay? At least build this.
Yes, that's totally fine. Can you hear me?
Yes. Are you able to write it?
Yes, it's fine. Yes, I'll write it.
So you want to write it now, or you would like to write it after the class?
I can write it after the class because we don't have much time left.
Okay. So you will write these two classes, and then just bear in mind, what I can do now is I can immediately pass you this, so that the point that I'm not able to pass you things immediately after the class, because I have classes after that. And typically before every class, I need I have too many students that studying almost similar syllabuses. So I need time before every class to remember what homework I have given and where did we stop, and then so that I make my brain, how to say, to be able to teach the student. I mean, if everybody is studying the same syllabus, definitely that will cause confusion. So not to avoid getting to understand, okay, this student have maybe a slow learner, so I need to do certain things for him or do certain preparation for him. Anyhow, what I want to say that that's the main reason that I take some time, because I have a queue, and then I have to tell, okay, so first I have this class in the morning, I need to pass him first his syllabus or even exercises. And then until it comes to you, then I will send it to you. But if I send this slide immediately to you now, then I think you are able to do it, right?
Yes.
So yeah, I think tell me.
It's fine. I can take a picture of it.
Okay, and even if you don't, I already sending it to you here. Okay, it's done. So, okay. But the point here, because I think if you write this class and you try to run, you will see no output, because you need to create an input from, you need to create a code, a main. You define the class, but you didn't create an object from that. how to create an object? Do you know how to create an object?
Creating an object, yes.
So I would say Julie equal part, oops, that need to be small. So part-time employee. And you pass it the name, Julie, and she's 23 years, and she earned 100 USD per hour. And that is, I'm creating Julie from this. So I will call the constructor, and then I would say print Julie dot get name, like that. And I would say wage. So that is, you have to, I mean, that is how you test this part-time employee class. So the wage equal Julie dot daily wage, like that. And you pass it maybe 5 hours. And then you print the wage. Did you understand what we did in these 4 lines?
Yes, I did.
Okay.
I did understand.
So I would say the final thing is that I take this. Oopsie, wait, give me a second. Give me a second. Let me see, why is it getting me? Yalla. Okay, good. So that is also going to be sent to you immediately now. So your part, you have to write these 2 classes, and you have to create an object from the full-time employee and test the get name and the yearly salary similar to what I did when I wanted to test the part-time employee. So far, is that okay?
Yes, it
Okay.
is.
Then if you have no questions, then I see you next class.
Okay, thank you.
Thanks a lot. Take care. Bye-bye.
Bye.